Rhythm of Physics today with you, and now we will talk about the magic of light, like about basic optics. This topic will explore as how we see and manipulate the world around us. So first we will talk about the seeing the world, like what is optics? Optics is a branch of physics that studies light, like how it behaves and how it interacts with matter. Ever wondered why a straw looks broken in glass or water? Or how glasses helps our classmates see the board? That's all about optics. There is some fun facts. Light is the fastest thing in the universe, traveling at nearly 300,000 kilometers per second. First, we will talk about what is light. Light is unique because it acts as both as a wave and as a particle. As a wave, like ripples in a pond, light travels in patterns. As a particle, light is made of tiny packets of energy called photons. There is we see the some picture of wave, and we can see that the highest point of wave called peak and the lowest point called throw. And we can see the direction of this wave in this situation like pass right. So the main law of optics, this is the law of reflection. When light hits a smooth surface, it bounces off. This is a reflection, where the angle of incidence equals the angle of reflection. And we see there the key point, like angle of incidence equal to angle of reflection. You know about this is the main, main fact, main point. We can see there is the some picture. We have, for example, some surface, and the in the middle of this surface, like what we have some line called normal, like it like breaks our surface, and we see this the incidence ray and reflected ray which have the equal angles. About specular reflection, on smooth surfaces light stays parallel, creating clear images. Diffuse reflection, on rough surfaces light scatters in many directions, preventing clear images. About refraction and bending light. When light travels from one material to another, like from air into glass, it changes speed and bends. We measure how much a material slows down light using the refractive index. The higher the number, the more the light bends. For example, imagine running from the pavement into deep sand. You slow down and your path might shift. Light does the same. You see in this picture, for example, in the first slide, you see the picture of the gas and some like tube, and you can see like our eyes see this picture like this like tube breaks, but you know that physically it like located right, like it's not broken, but we can see that maybe in like our main our brain like caught us like mm, this tube is broken because of this law of refraction. And for example, incidence ray which get into to some another surface, it refracted in the like another angle. If we had the some like incidence ray which came with angle of 60, the refracted ray will be 30. So let's talk about the main lenses and image formation. Lenses use refraction to focus light to a point or spread it out. We have the main two lenses. It's convex lens and concave lens. Convex lens, thicker in the middle. It brings light rays together at a focal point and used in magnifying glasses. In concave lens, thinner in the middle, it spreads light rays apart, used to help people see distant objects. For example, in our glasses, we have the concave lens. Because if had your егер сіздің көзіңіз яғни минуспен көретін болса, concave lens дегеннің аудармасы шашыратқыш айна деп аударылады. Яғни егер сіздің көзіңіз минуспен көретін болса, онда сіздің көзілдірігіңізде шашыратқыш линза бар. Яғни шашыратқыш осы линза айна мен алыстан көрмегендіктен қандай да бір маған түскен суреттерді барлығын яғни шашырату арқылы маған алыстағы затты көрсете алады деген сияқты. And you can we see that we use all of the parts of optics in our daily life. And also we can know about how our eyes work from the side of biology and physics. Your eye is an incredible optical instrument. First, the cornea and lens focus light. We see in this picture where is cornea and where is lens. The retina at the back acts like a screen. You see it. And interestingly, the image on your retina is actually upside down until your brain flips it. яғни біздің көріп жатқан затымыздың барлығы жалпақ тілмен айтқан кезде вверх ногами. Мысалы, қазіргі таңда менің алдымда планшет тұр, және де ол планшет мен үшін былай тұр. Дегенмен менің көзім оны былай көреді. Пока менің миым ол затты маған түзу алып бермегенге дейін. Сонда біздің миымыз әрдайым күнделікті сондай бір жұмыс жасайды, көз алдымыздағы барлық информацияны бізге аударып берумен атқарады деген сияқты. There is also some information about telescopes and microscopes. By combining multiple lenses, we can see things that are otherwise invisible. Microscopes use lenses to magnify tiny cells, while telescopes use large lenses or mirrors to collect light from distant stars. There is some key point. The more light an instrument can collect, the clearer and brighter the image will be. So we come to the end of this topic, and let's check your knowledge. You see these two terms like convex lens, concave lens, reflection, and about refraction. And you should match the numbers, terms with letters. And the meaning of this term. For example, convex lens. What is? A lens that converges light to a point. Or a concave lens that diverge light rays apart. Let's check your answer. So, convex lens, it's the C, a lens that converges light to a point. Concave lens that diverge light rays apart, and reflection, this is the light bouncing off a surface like a mirror, and the refraction, light bending as it passes between materials. So there is some summary, key takeaways. Today we talked about light dual nature, acts as both a wave and stream or photon particles, about laws of optics, like mirror refraction is equal and refraction bends light based on density, and the optical tools like lenses, mirrors, and our eyes helps us see and study the universe. So that's all. Thank you for your attention. See you in the next topics, next lessons. Goodbye.